Yeah, very good evening to all. Very good evening to all. Thank you for joining. Today's day 9. Today we are gonna see FSM Finite State Machine. So and then today we are gonna see FSM and we will try to write some interview questions like important, interesting questions like sum of the prime numbers up to 20, and then BCD conversion like a binary to decimal conversion. So we try to write code for these questions. So yeah, thank you for joining. So very good evening to all. Sri Lata, Kalyani, Sri Krishna, Akshay Kumar, Manmeet Lamba. Very good evening to all. Thank you for joining. So thank you for your presence in this class, master class. So very good evening to all. So let's wait for a few minutes. So there are only 28 people only that are watching. So let's wait for a few minutes. So remaining people have to join. So today's topic is finite state machine FSM. So this is a one method or a important state machine. It is used everywhere. It is used in all languages like Python, C, Java. So all the languages. If you want to do big project, if you have some complex logic, by using FSM, you can easily take the logic. You can solve one by one, and then you will get the required output at the end of the FSM. So thank you guys, thank you for joining. So Tamsi, good evening. Lakshmi, good evening. Pranav, good evening. So this is important topic. So we are writing the if you are writing the big complex code for your project. So if you take in any protocol like UART protocol, SPI protocol, or AXI, APP, AHP, Lambda protocols, we can write by using FSM. So if it is there is no FSM means there is no FSM technology means we have to write a complex logic. So it is very difficult to understand. By using the FSM logic, we can easily understand the code, how it is executed, how it moves from one state to another state. So we'll see in this session how it works. So it has it has two types of FSM. So two types of FSM machines it has. So we'll see in this session. So in this session we're gonna see only theory part of FSM. So tomorrow and then day after tomorrow we'll write the FSM code for Mealy logic, and the day after tomorrow we'll write the Varilla code for Mealy logic. So it has an overlapping and non-overlapping topics in the Mealy and Mealy. So there are two types of FSM. We know that Mealy and Mealy. So we'll see upcoming sessions tomorrow and then day after tomorrow. So today we are gonna see only theory part of FSM, how it is work, what are the types of FSM, and then how it is execute. So how many state it's need. So what is state and how it will change from one state to another state. So we'll see in this session, and then today we are gonna try to write some interesting question like binary to decimal converter in Verilog, and then some of the prime numbers in first 20 prime number, so up to 20 prime number. So we'll do find the prime number up to 20, up to 20 natural number, and then we'll try to add all the prime numbers we got from up to 20 prime number. So these are the questions we have to write. So thank you guys joining. So Anthony, good evening. So Vicky, good evening. Reddy, good evening. So we'll enter into session. So thank you for joining, thank you for presence. So basically FSM, so it stands for finite state machine. So it means the name itself, it having the finite state machines. So it having the states. So state means nothing but your goal. Your if you have one goal, you have to you have to do one thing and then do another thing. So like I said, step by step process. So if you want to achieve the goal, you can't directly achieve the goal. You can't directly achieve that. So for that, you have to do step by step. Firstly, you have to do initial step, and then you have to prepare something. So it is a step by step process. So it will process like a state changing. So if you are writing the complex logic, so you have to divide some states. So firstly, I have to do this state, and then based on that state only it will move to next state. So if the state is occur correctly, it works correctly, means if the condition is true, means it will move to next state. In the third state, it will do some operations, some condition based on our code. If it is it will working correctly, so then you can move to next state. So it is a state changing. This is the FSM, so finite state machines. We have the finite state, so we know the states. So it is based on our logic only. So if you want to do some things, you can use a less number of state, or else if you can use in large number, like a more than minimum number of states. So based on our logic, so some people using the some 5 to 10 states, 5 to 10 state for do some project. In other people can do some 20 to 30 states to do some to complete the particular project. So it's based on our dependency, based on our logic, we can write the states. So the state changing, so the main purpose of FSM is it will do by state. So it will complete one state, and then it will move to next state. So we can write the logic in the Verilog. So basically, FSM. So FSM stands for finite state machine. It's a mathematical model used to represent the sequential logic circuits. So and then it consists of finite number of state. I already said no. It is consist of finite number of state. We only giving the state, how many states it must contain. So and then transition between those states based on the inputs. It means if you do something. So basically, if you take my code, so I'm going to write the sum of the prime numbers up to 20. So up to 0 to 20 numbers we have natural numbers. So I have to 0 to 20 natural numbers, and then I want to do logic. I want to do write a coding logic for sum of the prime numbers. It means from 0 to 20 0 to 20 natural number. I want to identify the what are the prime numbers it having. So 2, 3, 5, 7. So these are prime numbers. So firstly I have to identify those prime numbers. This is my first state. So and then my second state is I want to add this what I got the prime numbers. So I want to add those prime numbers. So 2 plus 3, 5. So it will give some output. So this is the state. So firstly I have to do some identify the prime number. In the next state or next step, I want to add the what I got the prime numbers in the first state. So I have to add in the second state. So this is my logic. So we can write this way. So this is FSM concepts. So we are dividing our project logic. So we'll do by one state by state. So for transition of each state, transition of the one state to another state, it depends on previous state only. If the first state is fails, it will stay in the current state only. If it is first state is fast, it will pass, means it will move to the next state, and then that next state will pass, means it will move the another next state. So it will transit. It will how to say, it will go from state by state only. So commonly used we are using the FSM in digital design, control system, various applications like a traffic light controller, vending machine, and then communication protocols. So if you take a example for traffic light controller, the first state is red light, and then orange light, green light. So it will change by timing. So if you seen in traffic light, it will show some timing, like it will continuously decrementing from 55 to 0. So based on the timing only, it will change to next state. So red light is one state, and then orange light is a next state. So and then a green light is a third state. So green light is my output, so project completion. So red state is my starting stage of my project. So we can, it is example for the FSM. So we can easily uh, imagine how it is works. Means if you taken like traffic light, means if traffic light controller, it is based around the FSM logic only. So same like a traffic lighter, FSM will work. So let's see what is, so we seen the how it is work, and then what is the process of FSM. So it has the states based on the state condition, and it will, based on the state condition, it will move to next state. So this is the FSM. So let's see what are the components of FSM it having. So states, FSM it having the states. So main thing is state, and then input, output, and then state transitions, and then state registers. So these 5 things we need to build the FSM logic. So we'll see tomorrow how to design, first how to draw the FSM logic, and then how to write the Varilla code. We'll see tomorrow. Today we will see only the FSM theory, and then we'll try to write some code in interesting question. So these are the components in the FSM: states, inputs, output, state transition, and then state registers. So state means, so we are only giving the state. So how many states I have to do. So this is our own logic. So we can do any, we can use n number of state, or we can use particular certain states like a 5 to 6. So this is our logic. So inputs and then output is each and every state, it consists of input and outputs, and then state transition. So state transition, it works like a movement from one state to another state based on the input values. So while writing the code, you can easily understand how it works. So and then state registers. So each and every state I'm holding, I have to store my values. So for that I'm using the state register, hold the current state values. So these are the example for the, so this is a traffic light controller, is kind of Mealy machine. So Mealy FSM. So it's if you take an example for this traffic light controller, means the states are red, green, yellow. So inputs are it may be time or sensor data. It means some traffic lights are based on time. So it based on the timer only, it will change the red light, green light, yellow lights. Some traffic lights are lights are based on sensor. So based on the how many vehicles are in the road. So based on the sensor data, it will change the lights like a red to yellow, green to yellow, like that. So and then outputs. So output also we know that light colors are for vehicles and pedestrians. So outputs is nothing but lights only in the traffic light controller. So and then transition. So transition, it's a changes state based on the timer. So if you take the timer input, it will transmit one state to another state based on the timer. So and then we'll move to the types of FSM. So FSM, finite state machine, it has 2 types, like a Mealy machine and then Mealy machine. So there is a difference between, there are a lot of difference in the Mealy machine and the Mealy machine. So we'll see what is that difference. So firstly we'll see the how Mealy machine works. So Mealy machine works based on output depends only the current state. So if you take the traffic light controllers example. So if I'm using the timer to control the transition, so state transition. For that, if I'm using timer. So if my timer is so just based on timer, it will move to next state. So my current input is timer. So if I give some certain time period, so if I'm here how to say I'm writing logic for red light. So 5 seconds it must be glow red, and then after 5 seconds it will move to the orange. After 5 nanoseconds or 5 seconds it will move to the green. So I am giving delay or a count timer of 5 seconds for each transition. So once if the timer like a transition after timer is completed or executed, it will move to the next state. So once if timer comes to 5 seconds, it will move to the next state. So once on the current, if you see the current input for the state is timer only. So there is no previous state output or any other output as input, but each state is depends on only current input. So my current input is a timer only. So Moore logic is works based on current input only. It won't depends on previous output like a flip flop or a sequential logic. So it will based on the current input only. So and then it is simple to design and then analyze. So this example for the Moore machine. So and then let's move to Mealy machine. So Mealy machine is depends on both current state and the inputs. So current state and inputs. So current state, it store the previous output only. So whatever it give, so previous state it will give some output. That output will store in the current state. So it will store in the, so previous output is stored in the current state, and then it is also depends on current inputs. So based on the current inputs and the previous output only, it will move to next state. So how means for example, sequence detected. So sequence detected is nothing but you having the a number of sequence, you having the 1000 or 100 bits of binaries, like a 1011 1011. So like it's up to 100 bits. So you have to detect this particular sequence. So nothing but, so it's like if you, for example, if you take 0 1 1 1 4 bit of data, like a 0 0 1 1 1. So this is your 4 bit of data. You have to detect in your input sequence. So input sequence is it's contain the 100 bits of binaries. So you have to detect this 4 bit of sequence, how many times it contains. So for example, it starts from 1 0 0 1 1 1, and then 1 0 1 0 random value, and then it will start from 0 1 1. So from the first 20 binary, you have the two sequence, like two sequence of your whatever you want. So 0 1 1 I want, so it has in the first 20 sequence, so first 20 binaries. So it's like for sequence ratings, it must need to store the previous output. So why means, so for example, if you are having the sequence like 100 bits of binaries, you have to detect 0 1 1 1. So for first 4 bits, you got correct sequence, so I got one sequence. So I will move to other remaining binary bits. So it will start from 0, and then it will start from 0 0. You have 0 0 1 1 1. So in the fifth binary it's 0, and then sixth binary also 0. So in the, for according to the fifth binary, we got some first bit of my sequence, but second bit is 0. So it is not my first it is not my, it can't be a my sequence. So I think you understand. So in this in the sixth bit, it start from 0, and then 7th bit 1, 8th bit 1, 9th bit 1. So I got my second sequence. So for detecting the sequence, we have to depends on previous output and also current input. So this is a Mealy logic. So while writing the code, or while drawing the statements and changing, you can easily understand. So basically you have to take into mind is the Mealy machine is depends on previous output and current inputs. So Moore machine is based on current inputs only. So these are the difference between the Mealy machine and the Mealy machine and the Moore machine. So this is the first difference is output dependency. So we know that Moore machine is depends on current input only. So but Mealy machine is depends on both current input and previous output. It's like a current state and then inputs. So and then response time. So response time of the Moore machine is slower, as output changes only on the state transitions. So If you take in media mission, so based on our for example, if you take example for traffic light controller, the transition based on the timer. So based on timer only, it will change to next state. So there is a need for it must wait for that particular state have to complete or have to pass. If it is fail means it will stay in the same state, or it will go to previous state. It won't move to next state in the memory machine. So based on our state pass condition only, it will move to the next state. So it takes some time to get correct pass condition. So we can say that it is little bit slower. So response time of the memory machine is slower compared to the Mealy machine. So Mealy machine has faster response time. Why? Because of the output can change immediately with input. So it having the previous output and also current input. Based on that conditions only, it will give the immediate output. So it is faster than Mealy machine. So and then design complexity. So it is easier to design and debug in memory machine. If you take Mealy machine, Mealy machine means it will more complex due to input dependency. So and then state requirement. So usually requires more state to implement behavior. So if you write the memory machine, you have to it requires more state to write the memory logic. Why? Because of firstly you have to create the initial state, and then state 1, state 2, and then last state of your last output state of your memory machine. So in the compared to the Mealy machine, so memory machine need to create a more state compared to Mealy, but Mealy machine requires a less state only compared to memory. So and then output stability. So Mealy machine more stable, output remains constant until the state change. So there is no output change in the memory machine. So it will give the constant output once if the state is executed, and it will give the correct pass condition only. If the pass condition, based on the pass condition of the state only, it will give the output, constant output. So but in Mealy machines, it is not like that. The output can fluctuate with the input changes. So there is the we know that the previous output is based on previous output and current input. If the input changes, the output will be fluctuated, so it will be changed. So and then examples of the machines like for a memory machine, traffic light controller; for Mealy machine, sequence detectors. So these are the difference between the memory machine and then Mealy machine in the FSM. So both are easy to understand while writing your code and while drawing your logic circuit. So logic, it's not a logic circuit, it's like a FSM diagram. So it's like state changing diagram. So we'll see tomorrow. So and then we'll move to, so yeah, if you guys are really interested in this 21-day masterclass, you can convert this masterclass into 1 month internship on FPGA with certificate. So these are the benefits you will get in the 1 month internship on the internship program. So you will get the benefits of all 30 days recording session, all 30 days presentation, exclusive project codes, and you can downloadable also. So you will get the VIP community group for your doubt clearing and internship updates. So and then you will get the internship confirmation letter from IETE, and you will get the 90 days of LMS course access. You will get the assignment tasks, and then weekly live sessions for your doubt clearing. So we are providing you also IDEO for the resume building, mock test, internship. So and then you will get the internship certificate, and you will get the participation certificate from the 1 month of internship. So we are giving this internship at the discounted fee of just 999. Our regular fee is 3,999, say 3,999. So in this masterclass time, so in this masterclass session time, so we are providing at the discounted fee of just 999. So by using the registration link, you can register for the internship. So our organizer will post a link on chat box, or otherwise you can use these links you can see on your screen. So this is a limited time period offer, so it will close at 22 March. So these are the FSM theory. So we'll try to write some interesting interview question in Verilog. So we'll move to Verilog part. So today I'm going to use one like a parameter. What is the so we seen the parameter in first class. So sorry, in second class, how to use. We will see in this session how to use the parameter. So firstly, I'm going to write for binary to decimal converter. Binary to decimal converter in Verilog. So firstly, I write the module. My model name is BCD. BCD means binary to decimal converter. So and then just write module like a syntax for the Verilog. So this is syntax of my code, Verilog code, and then I write my port list here. My input is binary input, so I want to convert into decimal. So my input is binary, so I'm going to convert the 7-bit of binary data. So 7-bit of the binary input. So I like that binary. So binary is my input. So my output is decimal output. Output is decimal. So I'm going to use I'm going to write reg here. Why? Because of I'm going to use always block. So inside my always block I'm assigning my output. So I just have to use reg data type, and then I'm just add bit here. Why? Because of there is a, if you converting the binary to decimal, so if you are using the additional bit vector or size, it is you will get the correct output. So this is the main thing. Decimal is my output signal. So this is my signal, binary input, decimal output. So I just write it always at binary. So it means binary. If my binary, if my anything, if in my binary signal, so this is my signal binary. If any changes happens in the binary, it will execute the always block. So firstly decimal. So I'm assuming my decimal at the initial stage of the process, my decimal output it having the 0, and then I create one for loop here for I. So if you are using Verilog, you can use like this way, int I. So you can in the for loop you can, so in the for loop you can declare a like a variable, but in Verilog you can't do that. So I just declare here integer I. So and then I will start from 0, it will go up to the 7-bit, so 8-bit. So I less than or equal to 7, and then I equal to I plus 1. So this is my for loop. So and then end. So in the for loop I'm going to write the BCD to by so BCD logic, so that decimal equal to decimal plus inside the bracket I'm going to use shift like a left shifting. So binary of I shift I. It how it is work means, so if you take initially, so my binary input, imagine my binary input is 8-bit input is 0 0 0 0 1 1 0 1. So I will get like a, if you convert this binary means 8 4 2 1, so 1 5 8, so 13, so I will get 13 here. So firstly I will go easily, so just go 0 1 2 3 4 5 6. So this is 3, so I'm going to convert this binary to 3. So in the first iteration my I value is 0, so my decimal is 0. So see here you have just right here you have 0 equal to 0 plus binary of 5. So binary of 5 means this is my I input, sorry, binary input, and then I, so I equal to 0, this is my 0th index, and then I equal to 0. So here you can see I, so I means I equal 0. So I, in the first syntax I am shifting the 1 bit, so I am shifting 1 bit of I, so I will shifting the 1 bit here 1, so you will get the 1 here. So we'll get the 1, and then it will in the second iteration you will get the 2. So here you can see I means, so in the second iteration I equal to 1, so this is a 0th induction, this is a first induction. Here you will get here you will get 1 here, so it means firstly it have 1 and then 2. So decimal, previously we have decimal equal to like it is decimal equal to 1 in the first iteration. In the 0th iteration, imagine this start from 0, so this is 0th iteration. So in the 0th iteration we have decimal equal to 1. Same in the second iteration, in the first iteration, in the first iteration you will get sorry, I just one, here you can do 2. So previously we are having the 1, so 2 plus 1 3, so we'll get the 3 as the output in the second iteration. So remaining, if you doing means all the things having 0 0 only, so it won't execute that, so it won't add any, it won't add any difference in my output. So just write a test bench for that. So check my output, module and module, I just registered my signals here. So 7 down to of binary, and then where is my output? It has 11 bit wide, sorry 12 bit. Its decimal is my signal name. So and then I have do instantiation, BCD A1 So and then I pass my stimulus. So, so I give some delay here. First I will write my monitor. So it will execute it in the postpone region. So should have we seen it will monitor $monitor is executed in the postpone region. Without taking internship, what will you provide for these 2020 free sessions? So in the I want to see my output in the like decimal is my output. Decimal. So decimal equal to, so I'll just write this. So and then I give some delay 5 nanosecond, sorry 10 nanosecond. I just pass my 8 bit of binary input, binary equal to 8 bit of 0 0 0 0 0 0 1 1. So just run this. Test bench 10. So if you got any error means you will receive here. So in the transcript you can see the error. So error, my test bench 10th line I received error, like I mistakenly typed L. So I got error, that error in the 10th line. So I did correction here. So then I run this. Yeah, you can see here I got some correct output. Decimal is equal to 3. So this is a decimal conversion of the 3. This is my binary input. So if I change input like to 15, so 4 1 means I have to receive 15 in my decimal output. So you can see here at the initial stage of starting simulation of time I got only X, but in my after some delay I got some output like 15. This is my binary input. So this is the logic for the converting the binary to decimal. So you can see here decimal equal to decimal plus binary, left shifting of I. So here if it having 2 means it will do two left shift operation. So and then this is the logic for converting the binary to decimal converter in Verilog. So and then we'll try to write the another code for we'll try to write code for sum of the prime number. In first 10 numbers, first 10 natural numbers. So this is my question. So I have to write the first I have to write the code for first I would write the code for first 20 prime numbers. So not first 20 prime numbers, from 0 to 20 it having it having prime number. So I just want to print, and then I I have to add the prime numbers from 0 to 20. So this is my question module. So sum of the prime number. So I just write my module name is sum of prime number. So this is my module name, and then I am going to use parameter here. For this I am going to use module parameter and then n equal to 20. So and then this is my this is a way of declaration parameter. You can use if you are writing the module parameter, you have to use this hash symbol. If you are using inside the module, you just write parameter and then name, and you can assign the value for the parameter. So and then this is my I'm going to write output only. So I will get, so I want to see output only. My input is given in parameter, so I won't write that. Output into sum of the prime number. This is my output, and then in module. So firstly I'm going to use some I have to register some variable like a is prime. So is prime, this variable I'm going to use, so that particular value, so that particular number from 0 to 20 is a prime number or not. So if it's prime number, I'm going to store one temporary memory. So and then I will do addition for the what are stored in memory. I will do addition. So and then I will give the output in this sum of the total prime numbers from 0 to 20 numbers. So and then I want to add the prime numbers. For that I'm just using another variable like an integer total sum. So basically to integer data type having the 32-bit wide in total sum. So in the initial begin, firstly I'm assigning total sum having the 0. Having 0. So I'm going to use one for loop here. For loop. So integer int. So you can see here language system verilog or verilog. So in the CDA playground I can use system verilog. So just declare integer in the for loop only. For loop itself, it starts from 0. So it starts from 2. Why? Because of the prime number starts from 2 only. So I just do same thing. I just follow that from I less than or equal to n. So here n means I given like n equal to 20 in my parameter. So that 20 comes here. So I less than or equal to 20. So instead of writing the 20 here, I just write n. So if I want to change the n value, I just change here, means it will change whole code. So it will change whatever it having the n value, it will change whatever you given value, it will change that particular value. So this is the main advantage of the parameter. And then I plus plus, and then begin end. So in the I'm checking from 2 to 20, from 2 number to 20 number. I'm checking each and every number is prime or not. For that I'm just assuming all the number are prime number. So I just assigning 1. 1 means that particular number is prime number. So I just assuming that particular I number is prime number. So and then I add some another for loop here. Int j equal to start from 2, and then I will check up to j equal to like j less than or equal to I divided by 2. So and then I will say up to y I'm doing I divided by 2, and then J++, and then begin end. Inside the for loop, I am just written some if condition here. If I modulo of j equal to 0, begin end. If it is true means, my is prime will goes to 0. Why? Because of if I divide, like if you take I equal to if you take I equal to 5 or I equal to 5, j equal to 2.5. If I do modulo means, if I got some remainder means it is, you can divide. So you can divide, you got 0 remainder means it is not a prime number. So prime number is nothing but you can divide by itself the same number only, 1 and same number. If you are doing some 5 means it can divide 5 the if you take an example 7, so 7 you can divide by the 7 only. So and then so 1. So if you are 1 and 7 name itself, so number itself, if some particular number is divided by only the same number means we can say that it is a prime number. So if I modulo of j equal to 0 means if I get the remainder, so if you do some model operation means it will check the remainder only, it will give the output as remainder. Divide means it will give the quotient value. If you do the modulo means it will give the remainder value. If remainder is 0 means it is not a prime number, so it is divided by the other factors. Like if you take a 8, so 8 is 8, I equal to 8, so and then j equal to 8 by 2 means 4, so 8 by 4 it is divisible. So 8 by 4 model of the 8 model of 4 means it is divisible, you will get the 0 remainder, so it is not a prime number. You can see if I give is prime equal to 0 means it is not a prime number. So and then I won't go to next step, so I just break the statements. This is a break keyword in Verilog to break the execution of the for loop. So and then this begin end for this end for this end for this. So in the first for loop, so I am just to show the how to say, if is prime I means I will print that particular values. So based on the I values only it will finding the is prime or not. So here you can see is prime. If is prime is high means it will print what are the I value is prime. So is what are the I value is high means that numbers are that I numbers are prime numbers. So I just print that numbers only. If is prime is high means $display prime numbers. Or I can also use a total sum here. I can do also total sum here. Total sum. I'm doing some addition operation of the what I'm receiving the prime numbers. Total sum equal to initially it having 0, so total sum plus 1 I, and then I'm just printing the all values $display So the prime numbers, the sum of prime numbers, sum of prime numbers from 0 to 20 is total sum. I just assign sum equal to total sum. So whatever it having some total sum value, it will assign to the sum. So sum is my final output. So this is my code. I just run this to check my errors. So you can see it will check, it will give 2. So this is my output: 2, 3, 5, 7, 11, 13, 17, 19. This is my prime numbers from 0 to 20. So this is logic. Firstly, I am checking from 0 to 20. So n equal 20, 2 to 20. So in then each and every iteration I am doing model operation. In the second for loop, I model of j. So it will check. So it will check I. I means it will take an I value from this for loop. J value it will taken from this for loop. So firstly it will start from 2. First iteration from 2, and then comes here. This is my for loop, and it will do some this for loop. I just break this for loop only. I didn't break this for loop. So I just break this for loop, and then it will move to the second iteration of the this for loop. Is equal to 3, and then come here. It will do this operation. If it is prime means it will update, or it is not prime means it will update, and then break the statements. It will goes to this for loop I equal to 4. So this is the execution which is works. So this is the this is the way of writing the vanilla code, some logical questions. So you can try it yourself. So this is a converting. This is the vanilla code for finding sum of prime numbers. So use some logics like this modulo, and then total sum equal to total sum plus I. So these are the logics you have to aware of. You must to know why. Because of while writing the logic code, the industry peoples are interviewers only require this thing only, logical thinking. So you just need to build your logic thinking while if you are attending the interview. So thank you guys, thank you for listening. Five and 15. So I didn't receive any 15 value in my output. So I have some query here. 9 and 5 are not prime numbers. So you can check your browser prime number. Yeah, you can see 5 is a prime number, but 15 is not a prime number. So it is, you can divide by 3 and then 5. So there is a 2 factors. 3 is 1 factor and 5 is 1 factor. The main prime, if you want to know prime number, means that particular number is divided by the number itself only. It won't need additional factor. Like if you take a 15 means it has 3 and 5 as a factors. And then if you take a now 10 means you can divide by 2 and then 5. There is a 2 factors for 10. If you take these values, like a 2 has a only 1 factor, 3 has a only 1 factor, 5 has only 1 factor. So we can't divide by the another factor. So we can divide by the 5. We can divide by the 7 by 7 only. So this is the main. So this is the prime number. So this is the code for finding the prime number. So if I change my parameter here up to 100, So I will get the first 100. So I will get the prime number from the 100 value. So 100 numbers from 0 to 100 I will get the prime numbers. Yeah, you can see here these are my prime numbers from 100. So 0 to 100. So 2 3 5 7 11 13 17 up to 97. You can check also here, both are matching only 89 89 97 83 like that. So this is a way of writing the logic for logic. So whatever if you, some people may thought like say C, by using C language only we can do DSA. Like a DSA means nothing but there are some arrays like a stack array, tree. So these are things are used in IT peoples. So we can also write the DSA algorithm, so DSA logic in Verilog, system Verilog also. So in system Verilog having some class hoop concepts, hoop concept, and then arrays, and then queue it having system Verilog. So we can do the DSA in system Verilog also. It's a DSA is nothing but a data structure and algorithm. So we can do in the system Verilog, but we can't do in the Verilog. Why? Because of the Verilog didn't have class like a hoops concept, and then queue, multi-dimensional array. So it having only 2-dimensional array, so we can't do that. So this is for today. We'll see you tomorrow. Thank you guys, thank you for listening. So in the 21 day in master's class you will get the certificate, like a beginner certificate. At the end of the 21 and at the end of the master class you will get the certificate. So thank you guys, thank you for listening. We'll see you tomorrow.